Hi everyone. Today we're going to go over 4.1 notes, and these notes have to do with solving systems of equations by graphing. So before we get started, we'll talk about systems of equations. As we go through all of this semester, if there was one thing I need you guys to take out of Algebra 1 Semester 1, that one thing would be graphing. All right. We have seen graphs already before. We've graphed linear equations, we've done slope-intercept form, and we've done point-slope form. All right, that's the same thing we're going to do today, but when we talk about a system of equations, we're going to just be graphing two equations as opposed to just one that we have seen already this semester. So when in doubt, when you guys get to your final at the end of the semester, if you're in doubt of any sort of question, chances are you can always make a graph. So when in doubt, graph it out. And then if you're still in doubt and you don't remember your steps to graphing, we can use those H charts that we just did in our previous class. All right. So if you're really stuck and you don't know how to make a graph and you forget your slope and you forget your intercept and how to deal with that, we can always revert back to an H chart. All right. So to get us started, we have 3 vocab words, and these vocab words will get us right into what the topic is, all right? That's why I haven't really been explicit as to what systems of equations are, because that's one of our vocab words. So the first one is going to be an intersection, and just like when you hear the word intersection, we're thinking of where two lines cross each other, where they are going to intersect each other. Okay? And then when I move down, we're talking about systems of linear equations. So if you hear system, that's just talking about 2 or more. And of course, 2 or more linear equations. We've talked about linear equations already this semester. All right, it's your slope-intercept form, your y equals mx plus b, or your point-slope form, y minus y1 equals m parentheses x minus x1. And of course, with linear equations, we are always going to be graphing just lines. That's the beauty of linear equations. We know what we're going to have to graph. And then after graphing 2 or more linear equations, we have the solution to the system of linear equations. And the solution is the point, and sometimes the points, so we will put an S at the end. That does occur sometimes, in which a system of linear equations intersect. All right. So with that bit of information, we're going to move down to this little chart here. And we get 3 options. And the beauty of these 3 options is we've actually seen 2 out of these 3 already. All right, so if you read the top row, we have 1 solution. So if you think of how many times 2 lines are going to cross, 1 solution would mean that only 2 lines are going to cross 1 time. So if I were to work down, I was given 2 equations here, and they're graphed right below. So if I look at this picture, that one solution in which they are crossing or intersecting one another is at that point right there, and we'll call that point 1, 4. So if I asked you for the solution, you would say that the coordinate was 1, 4, and that there was only 1 solution. These lines are only going to cross at 1 point and 1 point only, and that point would be 1, 4. And so that's our key feature, is that it's going to cross at 1 point only. Or you can say at a single point. If I have 1 solution, I only have 1 crossed intersection of a coordinate. All right. Then when I move to the right, I have infinitely many solutions. And if you remember infinitely many solutions, it always came out true. If a function comes out true, even in this case, just like we did before, we will have infinitely many solutions. And so what that means is if I were to graph these two functions, you can't see it too terribly clearly, but the fact that you only see one line is because both lines are actually overlapping each other. These equations are actually the exact same equation, and you can actually go back in and verify. Take a look at y in this bottom section here. Well, what happened to y in order to get up to 2y? What did you multiply? You multiplied by 2. So if I multiplied every single term in this function here at the bottom, if I multiplied every single thing by 2, take a look at what happens. You get the exact same function up above. And the reason I'm allowed to do that is because I multiplied everything by 2. And so by doing that, you will recognize that the functions are the exact same function, therefore they should have the exact same line. So if I asked you how many times these two lines intersected each other, the fact that they are overlapping means that they are constantly crossing one another every single time along this line. In fact, there are so many times they're crossing one another that we can't even imagine how many. So we are going to say that there are infinitely many solutions because there are so many we can't even keep count. So their key features are that they are the same equation. And essentially they are two lines overlapping. If you ever see the same equation, including the slope, including the intercept, that are the exact same thing, you know that you are working with the exact same line. Therefore, they will have infinitely many solutions. They will cross each other infinitely many times. And last but not least is no solutions. Actually, I'm going to go back here. Remember here on key features, infinitely many solutions always comes out true. Okay, don't forget that little detail. And then for no solutions, I have, again, two lines that have been graphed for us. And notice these two graphs. They're never going to intersect one another, which means that they are parallel. They are parallel to one another. That's a key feature. And whenever they are parallel to one another, if you remember from Unit 2, whenever I have parallel lines, I know that I'm working with the same slope. So take a look at those two functions that I gave you. Take a look at their slopes. Their slopes are both 2's. So I know I'm working with parallel lines. All right? And by working with parallel lines, we know that they are never going to intersect one another. They're never going to cross one another. Therefore, I will have no solutions because at no point whatsoever are they going to cross. And remember, lastly, if we were to go to solve these, we'll do this in the next section. But we always want to remember that no solutions always will come out false when you go to solve. Again, that won't come into play until next section. All right. So we got a few examples here. The equations are not given to you on your paper, so please write those down right now. Just focus on A. We will go and talk about B here shortly. So for A's function, we have y equals 1/2 x minus 2. And we have another function, y equals 3x minus 7. Okay? Now, when in doubt, you guys get to your final. When in doubt, we're going to graph it out. Now, there's a way to save time here, and this is the way we're going to do it in class. But if you forget these steps at any point in time, you can always make an H chart. If you need coordinates, you can always create an H chart and figure out coordinates of that function. We practiced that last time, so please, if you need that extra help, you can always make that H chart. All right. So with this function here, let's start with the first one, this y equals 1/2 x minus 2. Notice the form that it's in. And remember, when we identify the form, we're going to put it on top so that we can make sure they match one another. So if I have y equals 1/2 x minus 2, I like the form, slope-intercept form, y equals mx plus b. So let's write that on top just to make sure it matches. And the fact that it matches is going to help me greatly. All right. So I can match up my m. I know my m is 1 over 2. And I can match up my b, and my b is negative 2. By knowing these two things, I can make my graph. All right. We always start with b. The fact that it's negative 2 tells me that my y-intercept is at 0, negative 2. And as soon as you know something, let's put it on our picture. So at 0, negative 2, we're going to put a point. And then my slope, if you remember, your m is always rise over run. Rise means you're going up when it's positive and down when it's negative. So whatever that numerator is on your slope, that's going to tell you if you're going up or down. And then your denominator is telling you you have to run. So you get two options. You're going to run to the right when it's positive, left when it's negative. Okay, this helps us determine our slope now. So if I go back to my fraction, I have a positive 1 in the numerator. So that's going to tell me I need to go up. And I have a positive 2 in the denominator. So that tells me I need to go to the right. So on that same point we just graphed, 0, negative 2, I'm going to go up 1, right 2, and continue the pattern so that you can make a nice straight line. And again, just like last time, if you can get points to the right, let's do points to the left. Again, continue that pattern. But this time we're going to go down 1, left 2. Remember, we're graphing straight lines, so if you connect the dots and you somehow have a squiggly line or something goes a little crazy, go back and check. So there's line number 1. Okay, we know how to graph these lines. The only thing that's different is now we have to graph 2 lines. So I'm going to change colors here. If you want to change colors on your notes, that's fine too if you want to use a pen. All right, same thing. Take a look at the function. Let's match it up, make sure it matches y equals mx plus b form. And then we can identify. My m is 3, but I like my slope to be a fraction, so I can figure out what's rise over run. So I'm going to put 3 over 1, so it's a nice fraction for me. And my b is negative 7, which tells me the coordinate I can start at is 0, negative 7. All right. Now, ideally, we want all of our coordinates to fit on the grid, but unfortunately, this question doesn't allow me to. But I'm just going to eyeball it. Okay, if you go down, there's only 6 spaces, but 7's not too far off, so I can graph it down here. That's just an estimate, negative 7. And then my slope is going to tell me I need to go up 3 and right 1. So from that 0, negative 7, I'm going to go up 3. Don't forget you started at negative 7, so you're going to move up to negative 6, negative 5, negative 4, and right 1. Continue the pattern. And if you continue the pattern, what do you notice about your other line that I have here in red? What did we end up doing? All right. And when you look, we ended up crossing our other line. So when I go to the directions that said how many solutions does each system have, by looking at this graph now, I see that I have exactly 1 solution because I crossed my lines at only 1 point, and then that solution is going to be at 2, negative 1. So if you have a solution, be sure that you tell me the exact coordinate so that we know the exact place in which they are going to cross one another. And essentially what that means is that when x is 2, in either one of my functions, I guarantee if you plugged in a 2 for x in either one of those functions, you should always get a negative 1 out because they share the same coordinate when we graphed. They share the same x value at 2, which means they will share the same y value at negative 1. And that's all for question A. For question B, all right, we're going to do the same thing. However, before we get to graphing, we're going to change our boxes on the grid to be by 2. So I'm going to mark them here. Every box is going to count as 2 as opposed to 1. And that's only because when I go to graph here, I want my picture to match and I want to be able to fit it on the grid. And the only way to do so is to change the values on the X and Y axis to go by 2s. It's not too terrible. We can still work with it. All right, so I'm going to do the first one here in red, like I did before. Match up your y equals mx plus b. All you're doing is just making sure they match so that we can keep going. And I'm going to put, let's see, where can I put it? I'm going to move it over to this side here. So my first function, my m is going to be -2. Again, we like it to have a fraction, so I'm going to put that over 1. And my b is going to be 10. And by having a b of 10, I now know the coordinate 0, 10. So let's get started. I can go up 10. Remember, every box is worth 2. So I have 2, 4, 6, 8, 10, which is right here. And my slope is going to tell me this time I have to go down 2 and right 1. Now be careful when we do go down to right 1. We're going to go in halfway on our box because we have to go to the right only 1. But remember, every box is worth 2. So if I go down 2, I can hop down to the next box. But when I move to the right, I can only go half of a box. Down 2, jump a whole box, move half of a box. Whole box, half box. And this all just has to deal with the fact that I just changed my box values. Every single box is going to count as 2 now, so I have to make sure I go halfway each time. Okay, connect my dots. Again, if your slope is negative and you go to connect your line, make sure your hiker is going down the hill. Little things to remind yourself as you go and you solve these. All right. Same thing, I'm going to do the next function in green here. Make sure it matches. And for green, I have an m of 1 over 4. And b is going to be 1. Make sure again that every box is worth 2 this time. So don't get confused. Every box is still worth 2. We're on the same grid. So at 0, 1, I'm halfway up that first box. And then my slope is going to tell me to go up 1. Right 4. Same thing, up half of a box, but when I go to the right 4, I get to jump 2 boxes. So up 1, right 4, up 1, right 4, up 1, right 4. And I can plot all the other values on the other side too, that left-hand side. But the reason I don't need to this time is because what do you notice when you graphed your 2 lines now? They're crossing. Again, at 1 point. So how many solutions will we have? Just 1 solution. And again, make sure you tell me the coordinate. And the coordinate this time, make sure it's every 2 boxes is 2. So the coordinate is 4, comma 2. Your x value is 4. Your y value is 2. And if you wanted to check, you could plug in a 4 into either one of those functions for x, and every single time you plugged in that 4 for x, we should get a 2 out for our y. There is a way to check these answers. Again, it's the same idea we did last class with those H charts, with plugging in those values and what have you. We can still apply that here if you wanted to check. Let's go to the second page now. Again, you have your 2 functions. We have c and we have d, so copy those down onto your paper. The first function on question C is y equals 1/2 x plus 3. Take a look at the form that's given in. Okay, that's a good form for us. We know how to graph that. But when we look at the second function, 4x minus 8y equals 16, that's not a form we necessarily like, so we will have to clean that up before we can graph it. All right, so we will practice that as well. So to get started, let's do the first function, same as always. Compare it, make sure it still matches y equals mx plus b. It does match, so I can identify my m and my b. And by finding my m and finding my b, I can now know that my first coordinate is 0, 3. And my m is going to take me up 1 to the right 2. So what we're doing here is basically the shortcut method. If you forget the shortcut method, either on your test or your quiz or your homework or your final, when in doubt, still are going to graph it out. But if you forget that shortcut method, make an H chart, okay? There is nothing wrong with an H chart. If you need extra paper, ask for extra paper so you can make an H chart. We know how to practice that, all right? This is just the shortcut method. So I can graph 0, 3. This time my boxes are back to 1s. I don't have to change the grid values on this. So I can go up 3, no problem. Then I'm going to go up 1, right 2, using my slope to tell me which directions to go. And I can get some coordinates on that left-hand side by following the pattern. Making sure I'm graphing a straight line. All points connect to a straight line, that's good. So I have my first line. All right. When I get to the next function, this 4x minus 8y equals 16, if I go to if I go to write it down and compare, we don't have a y equals mx plus b form, so I have to rearrange it, all right? And I'm going to rearrange down in this corner so that I can show my work. And we did this already, but we'll practice some more. Remember, we want it to say y equals. So if I take a look at my y right now in my function, and I highlight it there, I have to get rid of a 4x, and I have to get rid of that minus 8, that negative 8. All right? But I have to get rid of these two things in the correct order. So I'm going to get rid of the 4x first. And I want to completely move it to the other side. So if I'm completely moving the entire term, I have to use either addition or subtraction. And since 4x is currently a positive 4x, the only way to move it is to subtract a 4x. And whatever I do to one side, I have to do to the other. Remember, 4x and 16 are not like terms, so I cannot combine them. However, in the y equals mx plus b form, your x term wants to be first. So I'm going to draw an arrow and make sure that I'm subtracting that 4x in that first section there. And now if I work down, I have a negative 8y equals negative 4x. And that 16 was initially positive, so I'm going to make sure I keep it positive by saying plus. All right. Don't forget the negative on your 8. Okay, it was there to begin with. Make sure you bring that down. Now I have, again, I'm trying to get y by itself. So I want to get rid of the negative 8 this time, but be careful. Yes, it's a negative. You might think we have to add 8. All right. The reason we cannot add 8 this time is because 8 is attached to that y right there. And the only way to get rid of attached values, meaning they're multiplied right now, the only way to get rid of multiplication is to do the opposite, which is going to tell me to divide. So I have to divide not by just 8, but by a negative 8. Because when I divide by a negative 8, both of those will cancel each other out, leaving me with just that y that I'm looking for. And make sure whatever you do to one side, you do to the other. So we have to divide every term by negative 8. Simplify that fraction. Negative 4 divided by negative 8 is going to give me 1 over 2. X, it's actually going to give me a positive, so that's good. And then 16 divided by negative 8 will give me a negative 2. All right, all that works, so we can put it in slope-intercept form. So now I know what my slope is. And I know what my intercept is, which will then tell me my coordinate 0, -2. I'll make that here in green. And my slope's going to tell me I can go up 1 and right 2. Up 1, right 2. Take a look at what happens on your picture. If I connect the dots and make this line, what do you notice about the two lines? All right, they are both parallel. They're both going in the same direction. They're never going to cross one another. And if I know they're both parallel, double check. Take a look at their slopes. You had a slope of 1/2 here, and then we ended up having a slope of 1/2 there. So we've just confirmed that they are indeed parallel lines. And if I was asked the question, how many solutions are they going to have? You would tell me they have no solution because they are not going to cross one another at any point in time. They have no value that's going to be the exact same. And then we're done with question C. No solution on question C. Go ahead and try question D on your own. Again, you have one function, 5x plus 2y equals 10. That is not in slope-intercept form, so we first have to convert it. We have to move things around, just like you did in question C. The second part, though, is really nice because it's already in slope-intercept form, so we can identify our slope and identify our intercept. So go ahead and pause this video, try this one on your own, see what happens when you go to make your graphs, and see if you can get to a final solution. All right, so as you do that, I will practice this one for you so you can check your work. We have to first convert that 5x plus 2y equals 10 function. So I'm going to copy it down below my graph here so I can show my work. We have to move that 5x first, so I'm only allowed to use addition or subtraction. But since 5x was positive, I now have to subtract it. Making sure to subtract it to both sides. And again, I want my x term to go first, so I'm going to put it at the front of that 10 there. I get a 2y equals -5x plus 10. And last but not least, to get rid of that 2, I need to divide everything by 2, leaving me with y equals -5 over 2x plus 5. So that is the function I am working with. And with that function, I have a slope of -2 over 5 and a b of +5. That tells me I have a coordinate 0, 5 to start with, which is way up here on my y-axis. -2 over 5 is going to tell me I need to go down 2, right 5, down 2, right 5. I'm only allowed to have 2 points on this graph if I get it to work. Oh, excuse me, not down 2, right 5. Messed up on my slope there. Sorry, guys. Copied it down wrong. Let's backtrack a little bit here. Okay, I did all my work right, but I copied my slope down wrong. I flipped it when I shouldn't have. So I really have down 5, right 2. Sorry about that. Down 5, right 2. Because 5 was in the numerator, 2 should be in your denominator. So if I take that information, I'm going to go down 5, back to the origin, to the right 2, down 5, right 2. That looks a lot better, so I can make my slope and connect my dots and have my line. Now, what do you notice between your function that you just got and this new function that we need to graph? All right. They both have the same slope, which is good. Same slope is going to identify parallel lines, but more importantly, they have the same slope and they have the same intercept. So the fact that they have both that are the same, if I go to graph it, I'm actually going to run into the same exact line. So they're not actually going to be parallel to one another. They are going to be the exact same line. So even though they share the same slope, they're not necessarily parallel because they also share the same intercept, which tells me I'm working with the exact same line. So if I asked you how many solutions these had with one another, I know that they are constantly crossing each other every single time along this line. Therefore, I have infinitely many solutions. There are so many times that these two lines are crossing one another that I can't even keep count. There are so many that we're going to call it infinitely many. All right. So you guys have seen all three versions of the types of solutions we can have to systems of equations. We can have one solution where they cross one time. We can have no solution where they're never going to cross one another. And then we can have infinitely many solutions where they might cross infinitely many times because, of course, they are the exact same equation. So some questions here. I've provided you the next 3 questions. These came directly from years past finals. All right, so when we go through these next 3 questions, I would say they're very, very, very important because they came off of previous finals from years past. So they may come up again this year. All right, so these are the types of questions you might see at the end of the semester. For this question here, we have the functions f of x and g of x. So they're just lines. You have your f of x graphed here. It's that line. And then our g of x is graphed there. All right, they didn't give us the real functions, but that's okay. You'll see we don't even need the real functions. All right, so they're graphed below. And then the next question says to approximate. Another word for approximate is estimate. We're estimating the value. And we're going to estimate the value of x. That is a key detail. And of course, as we go through, when f of x equals g of x. All right, so we're saying when one line equals the other, which is what we just did. If we know one line is going to equal the other, that's the exact solution in which they are crossing one another. But on this case, we want the x value. Okay, and again, we want the x value because that's what they asked for in the directions. Okay, you guys have been submitting your answers as coordinates. This can be submitted as a coordinate as well, but at the end of the day, if it was a multiple choice question, make sure you're circling the answer that refers to your x value. All right, so we're looking where the lines equal each other. So where do they cross? And they cross right here. And then, more importantly, they cross at this point, but the direction said to approximate because that doesn't fall on a perfect box corner, which means I have to guess. I have to make an approximation. So I know that it's going to be roughly up to here where my x is. So it's definitely 2 boxes to the left. And then maybe about a half more. So my x value there would be at -2.5. And then my y value, we could say, that's close enough to -2. So we'll call that -2. But again, the directions didn't ask for y. The directions asked for x. So our final answer would be just the x value in which they are crossing. And we can approximate that to be about -2.5. All right. As long as your answer is between -2 and -3, there isn't a problem. All right. It's definitely not going to be -4 because it's not that far over. You're just taking your x value. So a good estimation would be about -2.5. All right. Another question you might see on your final is the next one here where it says the equations of 4 lines are given below. Take a look down. You have 4 lines. They're all different functions. All right. But it says which 2 equations, so we're going to only choose 2, form a system with no solutions. We just talked about a system with no solutions. If we go back to one of our questions that had no solution, what was special about question C once we developed and saw our graphs? We knew we were working with parallel lines. And more importantly, if I remember what parallel lines refers to, I know I'm working with the same slope. So on this question here, if it's no solution, I know I'm looking for parallel lines. When in doubt, you can graph all of these lines out if your heart desires. There's nothing wrong with that. Or we can say, well, which one of these lines have the same slope? And just do a quick check. All right. For line 1, this is not in slope-intercept form or point-slope form, the two forms that actually tell us our slope. So I'm going to have to convert line 1. All right. And let's just pause on that for now. Let's skip to line 2 and see if we can identify our slopes first. So maybe we don't have to convert in case one of them's already the same. So in line 2, we would consider this to be in point slope form. Okay, our y1 just got moved over to the right side, but technically that -7 is our y1. But our slope is in front of those parentheses, and we have a -2. We're just identifying our slope right now so we can tell which ones are the same so we can answer the question. Line 3, we have it in slope-intercept form. That's very nice. So I know I have a slope of 1/3 already. It matches just like all the questions we've already done. And line 4, again, this one is considered point slope form. Of course, with that -1 getting moved over, that still represents your y1. And here our slope is -1/2. So right now, if I compared all of my m's for each one of these functions, unfortunately, none of them are the same right this second. So I actually do have to convert line 1 and see if I can find my slope. We were hoping we didn't have to, but of course we can't answer this question unless we know what that slope is going to be. So we're going to do the same thing. We're going to convert it to say y equals. So I need to get rid of my x, and I need to get rid of that -3 if I'm trying to get y all by itself. So x is currently positive. More importantly, x is a 1x right now. So I'm going to subtract a 1x, subtract a 1x. And when I do that, I'm going to make sure it goes in the front. Make sure to bring your negative down with your y, -3. Then we have to divide by -3 to everything. And when we do that, take a look at your x here. It's a -1x divided by -3. So that's going to give me a positive 1/3 x. X can just follow at the end there. And then 9 divided by 3 gives me -3. So for my line 1, my slope, I can now identify is 1/3. If my slope here is 1/3 for line 1, and I see that my slope for line 3 is also 1/3, then I know that they are both the same slope. Therefore, they must be parallel to one another. So my answer would be line 1 and line 3. All right. These are the types of questions the district is going to throw at us. We have to make sure we can dissect these questions and break them down so we know what we can answer them as. All right. And then for the last question, it says determine which of the ordered pairs is a solution set of the following equation. All right. Lots happening here. Well, we're given two functions. We aren't given a graph, but this is why I say when in doubt, graph it out. If we only know how to solve by graphing right now, we can try that. All right. Another method, in case you're curious and you think this might work, you know that these are coordinates, so they represent your x and your y. Can you plug in a 3 for x and see if you get a -2 out? But it has to work for both. So if you plug these in, it has to work for both functions. And we practiced plugging these in last class with the H chart, okay? You have to get those two values out in order for it to work. So really, if you plugged in a 3 into that first function, you would get a -2 out, so that would work. However, when you plugged in a 3 into the other function on the right there, you would actually get a -6. So it wouldn't work that way. All right. But just because we were practicing graphing today, let's just use a graph. There's nothing the day of the final that says you can't make a graph. In fact, they actually provide you with your own graph paper on the day of the final as well. So if you want to just go and use that graph paper on any question, you have it there as well. When in doubt, graph it out. There is nothing wrong with that. So that's what I'm going to do here. I'm not going to focus on plugging things in because I want us to practice the graphing. So one of these answers has to be correct. I look at the first function. My slope is 1, but let's make it a fraction. And my b is -5. That tells me I'm going to graph the coordinate 0, -5. And then I'm going to go up 1 and right 1. And again, we're just eyeballing. I understand this is a graph that we have to draw on our own, but it's okay. We can survive. Go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. So it's going to look something like this. Then we can go ahead and graph the second function. So our slope is -3. Let's make it a fraction. Put it over 1. And my b value is 3, which tells me the coordinate 0, 3. And my slope's going to tell me I need to go down 3 and to the right 1. I'm going to graph that in green here. So 0, 3 is up here. Down 3, right 1. Down 3, right 1. And continuing on. Make my line. And I'm saying which one is a solution set. So look here, you actually happen to cross one another. And if you're struggling, if your freehand graph isn't the greatest, take a look at what quadrant that's in. That's in the 4th quadrant. So we know that our x has to be positive and our y has to be negative. So if your function or if your graph isn't the greatest, take a look at your function. You know that this coordinate has to be positive x, negative y, so that automatically is going to cross off b. That's not going to be an answer. All right, so we're left with with a and c. I can actually identify this. It is at 2, -3. 2 to the right, 3 down. So I know C is my answer, but there's little tricks that you can also use. You know this stuff about your graphs, so you can eliminate answers if you need to. If your graph doesn't come out the greatest and you can't read it very well, revert back to the basics. You know it's a positive x, you know it's a negative y, and we can go from there. All right. So that is all for section 4.1. Remember, you do have your homework tonight on teams. And with that, you will also have a quiz on one of those questions from your homework, all right? If you want to know what that question is going to be, because it's not written this time on your homework, send me an email. We can let you know, all right? Nothing wrong with preparing yourself for your quizzes. Graphing. Make sure you know how to graph slope-intercept form. That's the main takeaway from today's notes. If we know how to graph slope-intercept